Good day everyone, I'm Janice Sultan and this is Group 4 presenting the transfer of energy through trophic levels. Now let's start by understanding trophic levels. So what exactly are trophic levels? Trophic levels refer to the position an organism holds in a food chain or food web. They represent the different steps in the transfer of energy through an ecosystem. The primary producers such as plants and algae make up the first trophic level. These organisms are able to capture energy from the sun and convert it into chemical energy through photosynthesis. The next trophic level consists of the primary consumers, which are the herbivores that feed directly on the producers. Then there are the secondary consumers, the carnivores and omnivores, that prey on the primary consumers. Tertiary consumers and quaternary consumers occupy the higher trophic levels as they feed on the lower level consumers. This hierarchical structure with each level feeding on the organisms from the level below is what allows the flow of energy through the ecosystem. Now let's have John Matthew Pabia to describe the transfer of energy through trophic levels.
The transfer of energy in an ecosystem follows a unidirectional path, starting with the producers. Organisms like plants, algae, and some bacteria are able to capture energy from the sun and convert it into chemical energy through the process called photosynthesis. This chemical energy is then stored in the form of organic compounds such as glucose and starch. The producers, as the first trophic level, provide the foundation for the flow of energy in the ecosystem. They serve as a food source for the primary consumers, which are the herbivores that feed directly on the producers. When the primary consumers eat the producers, they obtain the stored chemical energy. However, this transfer of energy from one trophic level to the next is not perfectly efficient. Some of the energy is lost as heat through the process of digestion and metabolism. It is estimated that only about 10% of the energy available at one trophic level is actually transferred to the next level. This means that for every 1,000 units of energy captured by the producers, only 100 units are available to the primary consumers, and even less to the secondary and higher level consumers. Energy moves up the trophic levels from the producers to the various consumers. The amount of available energy decreases significantly. This results in the characteristic shape of energy and biomass pyramids, where the base is broad and the higher levels become narrower. The loss of energy at each trophic level is fundamental constraint on the number of levels that can be sustained in the food chain or food web. The limited transfer of energy is a key factor that shapes the structure and dynamics of ecosystem. Now let's have Ms. Damolo to explain how producers and consumers make the flow of energy possible through ecosystems, food chains, and food webs.
Thank you, Fabia. So, when organisms die, they are consumed by digivores and decomposed by bacteria and fungi, sustaining energy exchange. In ecosystem, complex food webs emerge with animals feeding at multiple trophic levels. For instance, a Philippine forest exhibits diverse interactions among consumers and food sources. In marine environments, phytoplankton form the base food chains, eaten by zooplankton, leading to a cascade of consumption up to larger organisms. Decomposers like bacteria and fungi complete the cycle by breaking down dead organisms into nutrients for plants. Now for the food pyramid, let us have Precious Eve Bukau.
As energy is transferred from one trophic level to the next, there is a significant loss of energy at each step. It is estimated that only about 10% of energy available at one trophic level is transferred to the next level. This means that for every 1,000 units of energy captured by the producers at the base of the food chain, only 100 units are available to the primary consumers. And from the primary consumers to the secondary consumers, only 10 units would be available. An example states this: 10,000 kilograms of plankton that photosynthesize are needed to support only 1,000 kilograms of plankton that do not photosynthesize. planktons that photosynthesize are producers used as food by the planktons that do not photosynthesize, the primary consumers. In turn, 1,000 kilograms of primary consumers would support only 100 kilograms of small fish, which in turn would sustain only 10 kilograms of lapu-lapu. At the highest level are humans. Notes that only 10 kilograms of lapu-lapu would sustain only 1 kilogram of the biomass of humans. This demonstrates the energy limit as the number of trophic levels increases. Each successive level has significantly less energy available due to the losses at each step. The explanation states that due to the loss of biomass at each level, 10,000 kilograms of plankton at the base of the pyramid would only support 1 kilograms of humans who are the top consumers. So as the food chain becomes longer, with more trophic levels, the amount of energy available at the higher levels becomes increasingly limited. This places a natural cap on the number of trophic levels that can be sustained in given ecosystem. In summary, the energy limit is determined by the approximately 10% transfer efficiency between each trophic level. As the number of levels increases, the available energy becomes progressively lower, containing the length of the food chain.
Understanding the one-way flow of energy through food chains and food webs is crucial for understanding the functioning and dynamics of ecosystems. Energy is the most fundamental factor controlling the types of organisms that can exist and thrive in a particular ecosystem. This understanding helps recognize the interdependencies between producers, consumers, and decomposers and how disruptions to energy flow can impact the entire system. Thus, comprehending the one-way transfer of energy is essential for understanding ecological relationships, energy limitations, and the broader dynamics that shape ecosystem structure and resilience. And that's all of our presentation about the transfer of energy through trophic levels by Group 4. Thank you for listening.